works. Good. Okay. Okay, the first step is exactly the same. Oh, first question for the whole room. Look at the equation that they give you for 21. Raise your hand and tell me what's different from this equation as compared to the 105 problems you have done so far in this unit. What is different between this equation and the other 105 problems you have worked on for this unit? There's a significant difference today. This is the new part. Michaela?
They equal the numbers.
All of the other problems started out with f of x equals or y equals. Or maybe they throw in a g or something. But okay? How many saw that? 2 points. What was the objective of the other 105 problems? 10. So again, you can't get lost in steps in this class. You have to keep track of the big idea. So the scuba tank tipped over. It's all good. Very nice water bottle with there. Color is cool. It's a good color. Hands. What is the objective of the other 105 problems you've done? Come on, hands. Think with me. Like you did a bunch of steps. What was the end goal of the other 105 problems? Sydney?
Find the derivative, or like make the derivative able to be used with a calculator, or like by hand without a calculator, something like that.
That is perfectly stated. No, really. Listen. Michaela, shoot. Sydney is remembering that perfectly. The other problems started out with like y equals, I don't know, 2x to the 7th plus 5x or something. And we take the derivative of both sides, and we get an equation that we could just plug in our calculator. And this would find for us the tangent slope at any point. But we do all these steps using the rules to get to an easier equation, one that is a bit easier to manipulate without a calculator. So our goal is to find the simplified version of the derivative equation. That's what we're trying to do in all the previous work. Questions? I mean, of course you said it. 2 points, 3 for Sydney. Okay, the goal here is exactly the same. The goal here is exactly the same. We are trying to get an equation down here at the bottom that's going to say dy dx equals. Okay, so don't change your mindset. It's still the same objective. Question? Awesome. So can I erase this? Cool. So we start out exactly the same way. We take the derivative of both sides. So we say d of 5 over dx. Now, we're trying to get a little better at writing less. So raise your hand, please, and tell me, if I take the derivative of all of this, so I have d dx of all of this, hands up, what will be the first rule I will use? Hands. What's the first rule that's going to be used once I take the derivative of both sides? So Sophie? Who knew it? 2 points. So I'm going to do that part in my head. So I get d of 3x over dx plus d of 2y over dx plus d of 3y cubed over dx. Question? Because everything's just adding, don't need any parentheses. That's what you said. Anybody else? Okay, hands up. Without writing any extra steps, what will this become? Hands. Come on. Hands. What does this become, Carrie? How many do it? 3 points. This one's 0. This one's 3. And here's a new thing today. Notice here that you take out the 3, and you're left with dx, which equals 1. 3 times 1 is just 3. Pretty comfortable? Okay, what's different today is, because the equation we start with doesn't have y alone on the left, we don't start with y equal, we end up with this different situation. I pull out the 2, and I'm left with dy dx. dy dx is not equal to 1. So this becomes 2 multiplied by dy over dx. That's what's new today. Question. We're not using the rule differently. We're using the rule exactly the same way. The only difference is instead of ending up with 3 multiplied by dx over dx, we get 2 multiplied by dy over dx. Question. Okay, one caution. After doing a few of these problems, most students will start to ask me, why don't we just solve for y in the beginning? Like, why not convert the problem to look like the other 105 problems you've already solved? The answer is they almost always give you a problem where that is either impossible or extremely difficult or not helpful. So I would say 99 times out of 100, don't isolate y. It's very rare that that would be helpful. Don't forget that. I've seen that be a problem in past years where people come to me and they're like, I can't do this. I'm like, well, how'd you start? I tried to solve for y. I'm like, why did you solve for y? I told you not to solve for y. So, okay. Question? Good. Keep going. This one here you can do as a shortcut as well. Remember, we just use the power and multiplying constant rules together. So 3 times 3 is 9. Then I'll have y squared, but instead of dx over dx, I end up with a dy over dx. This is why I told you in the very beginning to write dx over dx for a while to develop the habit. So when we did a problem like this, you would remember, oh yeah, I still have dy over dx. You wouldn't forget. Question. This process is known as implicit differentiation. That's the word they assign to this process of taking the derivative when we don't isolate for y. In the other case where y was already isolated, that's explicit differentiation. So you don't need to remember the words. It's just so you take another class and the math teacher says it. Oh yeah, I remember us talking about that. So. Question? Cool. Okay, last thing. Hands up. What's the goal of this process? What am I trying to get down here? Hands. What do I want? What do I want at the bottom of the page? I mentioned it before, and I erased it. What are we looking for, Kylie?
dy over dx equals.
Perfect. I want dy dx equals. And I'm pretty close. Here's dy dx. Here's dy dx. It's just an equation like this. You know? 2x, let's see. All we really have here is this. We have 0 equals 3 plus 2 times, we'll call it capital A, plus 9y squared capital A. We're just trying to solve for capital A. That's all we're doing. We want an equation that says dy dx equals, we just do some algebra. We need to talk more about it.
Did you just change the dy dx to A?
Only to, I was hoping to write something that when you look at it, you'd say, oh, that feels more familiar than this, but it's the same thing.
Okay.
So we won't do this. It's just hoping to help you feel more comfortable with this. Question? Awesome. Okay, so let's see. Move the 3 over here. Negative 3 equals 2. An abbreviation for dy dx is y prime. I do think it is important, okay, just like I told you to always write dx in the beginning, write dy dx once, at least. Once you write dy dx on the next line, if you want to change that to y prime, that's okay. But there are some problems in the future where if you forget to write dy dx, it could cause trouble. So write dy dx once. On the next line, if you want to abbreviate, it's perfectly fine. So now I have plus 9y squared y prime. Question? Okay, to get the y prime alone, I factor. -3. Back up, hold on. Y prime, 2 plus 9y squared. Question? Cool. And divide. So -3 divided by 2 plus 9y squared is equal to y prime. So, question. You want me to talk through anything again? Say it differently?
Did you like divide the y prime by 2 just to get rid of the y prime? Like when you're factoring?
What I noticed is right here I have 2 factors. Here I have 3 or 4, depending how I think of it, 5, I guess. Y prime is a factor in both terms, which means I can legally divide this by y prime. The result is 2. This divided by y prime is 9y squared. To maintain equality, if I divide, I have to also multiply. Question? In fact, let me show something over here. This might help some people. Watch this for a minute. Everybody look here. Everybody look. Everybody look. All eyes up. Okay. Factoring is a huge part of the class every day for the rest of the year. We just keep using it over and over again. Most teachers never show this, but I have found this helps some people. When we factor, what you really do is you multiply and divide simultaneously. So here's my expression. I'm going to take this expression multiplied by y prime. But to make sure I still have the same thing, because you can't change the equality, I also divide by y prime. If I multiply and divide by the same thing, I'm just multiplying by 1. It's the most common algebra trick we always use. Multiply by a special version of 1. Are we good here? Okay. This, because of how this is arranged, you can think of it as y prime here over 1, and then this fraction can be broken into 2. So you have 2y prime over y prime plus 9y squared y prime over y prime, like so. Because fractions multiply straight across, so the fractions add with a common denominator. So this is the same as this. So these divide to make 1, these divide to make 1. That's how we end up right here with y prime times 2 plus 9y squared. Sorry. I don't know if that helps or not, but that's what you're doing when you factor it. So. Questions? That's why you'll hear me say, oh, when we factor, we divide, because you are. Cool. Hands up. What's the purpose of this equation? Show me your hand. What's the purpose? How would you use this equation in some future problem? Sarah? Close. No, you're close. So we have a curve, okay? The curve is described by this equation. That means we can plug in an x, find a y. Plug in an x, find a y. We could then make a picture of what the curve looks like. This equation here is for finding the slope anywhere on this curve. If I want to know the rate of change or slope right there, if I know that y coordinate is 7, I plug a 7 into this formula, this will tell me that tangent slope. If I plug a 7 into this formula, I can solve for the x coordinate here. So I could find what this x value is. So this is how I'm going to use this y coordinate to find the x. This one's going to tell me the slope. Okay, how many know it? 20. Question? Yes, no. Stop that.